Welcome everybody, and thanks for tuning in to the Daily Space Weather video. I be your host, Dan, aka smAsho. And if you've noticed, the fire has turned back to the blue color. Thanks everybody asking for an explanation of what that was all about. Decided to start things out with matching colors in the 131 angstroms view from the SDO. It's a 48-hour video. And while Sunspot 2765 has degraded, and while there has been a coronal mass ejection on the opposite side of the sun, which is causing NOAA to scratch their heads and be very confused about it, Sunspot 2765 has maintained its beta classification as it retains a trailing umbra of opposite polarity. We'll show you that momentarily. There is a filament eruption that you can see there too, which is causing people to have their heads way, way deep in their you-know-whats with the analysis of this. So NOAA has sent out a thing that says we're poring over the data to see if there was an Earth-facing coronal mass ejection. And what they were seeing was the one on the opposite side, which looked like a halo on the LASCO C2 and C3, and I'll say nothing else about it. By the way, this video is being streamed live on Twitch. It's twitch.tv/smAsho for all of you folks who'd like to see the stuff as it comes out. Before we head to HelioViewer, let me put up my test pattern for a quick moment and make sure that I have the chat open, and indeed I do. So if you're viewing live, check it out. This is what I see. That's what it looks like. And let's look at the fields here. So there you can see the fields. And so that leading umbra has one small trailing umbra about here, I believe it is. So the lead umbra is there, the trailing umbra is where that first dot is, and that's what makes it a beta class sunspot group. Here's the 304 angstroms current view. Let's make sure that's the most current view. There's the refresh. So Sunspot 2765 lives on as a sunspot. Here are some images in 94 angstroms. Please bear with my relatively slow computer. Yes, we do a lot with a little around here. And if it would please play, I would just be delighted. No, that's okay, I'll wait. Okay. There we go, I just hit refresh and we are good. There's the 94 angstroms view. It's a 48-hour view here, by the way. Another great image of that filamentary behavior. And that, as far as we can tell, has collapsed back into the chromosphere. I'll let that play through a second time, as we've got a lot of things to get to, and you may even hear me rant about things that have nothing to do with space weather. Or do they? Anyway, two little filamentary eruptions there kind of in a row. Here's the active region that's setting in the northwest. That's 171 angstroms, which is one of the ionized states of iron, by the way. And here's the same period of time, South Pole region, Sunspot 2765. Great views of the filamentary eruptions there. And we may gather even higher res views of this later, as that was a very interesting filamentary behavior there. Let that play through one more time. KP index is down to 2. 10.7 centimeter radial flux is at 72. And by the way, this is going to be changed into this shortly. So that you won't continue to see this plot here, which is fine. It should be a better graph anyway. As we count down to the solstice, we invite you to the smAsho solstice stream. It'll happen on June 20th. It'll start at about 5:15 Eastern Daylight Time. So join us there. We'll feature a call-in sort of a format. We may have the line turned on and off at some points throughout. It'll probably be about a 1 hour stream, we expect, maybe an hour and a half, depending on what else is happening at the time. So join us for that. And there's the number for the smAsho VoIP line. And if you call me now, I will not answer because I do not have the smAsho VoIP phone on me. So definitely give us a call then. And be the first YouTube channel that you talk to, or the first whatever. We're going to be on Twitch, on YouTube, and on Facebook, so give us a call. Be the first to call us all winter or all summer, depending on which hemisphere in which you are located. Again, there's the VoIP line number, 610-936-9799. Next, looking at the solar system, there's where stuff is now. There's where stuff will be in a week. And I've been having the most insane Jupiter outside the bedroom window. Insanely bright right now. And it's going to continue to get brighter. So that's something you can see if you're up before dawn. Speaking of being up before dawn, we do it daily. So we can show you our cosmology segments. Today we've got some cosmology segment and some cosmology lullage. And we're going to be talking about things that people may not consider to be in the subject of cosmology, and others do. Why is that? Well, I'll tell you during the cosmology segment. Before we get into that questionable stuff, we're going to look at some transients, just 2 of them. These are the X-ray emissions from Sagittarius A star, the core of the Milky Way galaxy. Down here in the bottom left in the blue, those are the daily. And up here, this is the historic. So here you can see this data goes back to 2005. And it's a pretty consistent source. The only other one we're going to look at today is Cygnus X3. Not for any particular reason, other than it's one of the pole stars. It's also the most intrinsically bright object. It looks like it may be going back down to a quiescent state. So you see this level down here is off of this graph. That would be down here on this graph. So we had a very strong transient out of it right here about 2 weeks ago. And it may drop into a quiescent state again, as we saw it kind of peak, and then it kind of sputtered. Cygnus X3, massive X-ray binary, otherwise known as Deneb. It's a weird object, and you can read about it on smashamash.com/forum in the cosmology forum. Next, we're going to look at cosmic rays. First, Apatity and Barentsburg. And there are those. And let's see. Pretty flat at Apatity over the past 30. And a significant uptick here at Barentsburg over the past 30. Next, Athens, Greece. Going much farther south here. And these are all pressure-corrected data, if you're wondering. And there's the pretty flat graph, a slight uptick at Athens, actually. Slight uptick over the past 30. If you're wondering what cosmic rays are, they're primarily hydrogen nuclei, so extremely reactive particles traveling at extremely high speeds. Mexico City sees an uptick as well, so check that out. You see an uptick there at Mexico City. An overall slightly upward trend over the past 30. And last but not least, we'll look at Oulu and Antarctica DOMC. So there's Oulu. Flat to slightly down there. And DOMC Antarctica is flat on the past 30. If you want to monitor those yourself, be my guest. Don't take my word for it. Just look up the network of cosmic ray stations. We used to include that all in the things, in the video descriptions, but it's just not necessary. Talk about COVID for a minute. Have you noticed some conflicting reports about what destroys the virus, what doesn't destroy the virus, what's healthy, what's unhealthy, whether you should inject hydroxychloroquine into your eyeball with using a chainsaw, if you should, you know what I'm talking about, right? You've seen some conflicting reports and a little bit of propaganda on the internet. Have you seen a little propaganda? Anyway, now people are still arguing about whether sunlight, that is UV radiation, would destroy viruses. A ridiculous notion. I think this might have to go into the sharticle category. It's on SciTech Daily. And have hope, folks. The world's still not ending. Here is a little silver lining that everybody's going to miss. A new killing mechanism discovered in potent natural antibiotic known as Teixobactin. Teixobactin, folks. It's a game changer. It could cure MRSA, which, by the way, kills tons of people in places like skilled nursing facilities. So that's another good article there for you. That one, once again, on SciTech Daily. And if you want to read more about Teixobactin, feel free. Hopefully it won't turn into some kind of a nightmare. The mechanism of action has to do with cell walls. And it's basically a new type of bacteria. I mean, a new type of antibiotic, and it's natural. So this could be a huge deal. And it looks like Novo Biotic Pharmaceuticals has been issued 2 patents. So there will be financial incentive. Let's look at a sky chart. Oh, and by the way, the reason we talked about viruses and bacteria is because some people think they come from space. Something going on with shutting down STEM, particlesforjustice.com and shutdownstem.com. Okay. Here's a sky chart. By the way, we streamed the video at 4:45. We got up to look at all this data, so you didn't have to. Anyway, here's where stars are. And if you get up around sunrise, let's see here. You're going to have Venus rising before the sun, which will give you an amazing, amazing view of the morning star, 3rd brightest object in the sky, Venus. And let's get back to data here, as we've ended the cosmology segment by going into the GOES X-ray flux, which you could argue is cosmology as we look at other stars with X-rays. Are they looking back? That's the real question. And the GOES X-ray flux is flatline. No significant X-rays out of that sunspot or the active region. Next, looking at the proton flux, to see it's totally flat. No surprises there. No big coronal mass ejections or anything like that. Nothing expected to be a proton event. And we have seen fluctuations here in the solar wind lately. You see the BT-BZ is all over the place. And we are in the North Pole current sheet right now, as we stated in the title. A couple little phi angle shifts here, mostly staying around the 120 degree mark over the past 12 hours. And we see an enhanced solar wind, so there should be some slightly more beefy auroras. We'll show you the forecast momentarily. Current solar wind speed up to about 478 kilometers a second. That's 478 kilometers a second. Solar wind density 7.96 protons per cubic centimeter. And I'm expecting this to drop back down. It looks like a weak solar wind coronal hole wind stream to me. Possibly a trailing coronal hole wind stream from the last one, because it's the density barely even spiked. It went from 2 to 12. And since this is already sputtering in terms of the speed, this is probably going to drop back down to background levels if you had to know my forecast, which I guess now you do. We're looking at all 3 geospace magnetosphere movies today, as we see some fluctuations in the solar wind coming in, so it should be interesting. We'll show you the velocity, the density, and the pressure, but I won't show you me because I'll have to vanish. And we're going to show you the density in a minute. First, I want to take a quick look at the chat. By the way, please leave a comment on whatever platform you're viewing, and we thank you. Here's the density. And it's all looking pretty normal now. It's like a decent solar wind there. Nothing too crazy. And allow me to return. Here's the pressure. Let me rewind that here. And these are all 4 hours, folks. And if you're new to the channel, thanks for tuning in. So we see significant pressure here, both in the bow shock area and the magneto tail. The sun would be on your left from these images, folks. And you can see the Earth image there, that's the planet part. You can see the left side of that is illuminated white, and the dark side is black, where the magnetotail is. And here's the geospace ground magnetic perturbations. And we're going to show you the auroral forecast in a moment, so that if you're viewing from a high latitude, you will be able to see what you may be able to see, if you can see it where the seeing is good. So a little bit of ground magnetic perturbations there. Here are the auroras, and not looking too bright, really. Mostly southern hemisphere. There's a little bit of a kick up in both polar regions. So southern Greenland. Check spaceweather.com later today. You'll probably see some great images. They've always got a great auroral gallery there. GOES magnetometer has been seeing some spikes. And again, we are solidly in the North Pole current sheet. There's the magnetometer. Here's the current sheet, at least the polarity of it, and the magnetism. Now this is part of the National Sunspot Observatory, folks. This uses 51 ground-based magnetometers, as well as magnetometers on stereo A and B. The data is 1 hour and 20 minutes old, and keep in mind the magnetic environment can suddenly change. I thought we saw some activity on the opposite side of the sun. It looks like that may have subsided now. Or perhaps it's cycle 24. We'll have to wait and see on that one, as it's not even visible yet from stereo A. Here's the line of sight field plot, which shows you the B field in blue. That's also the interplanetary magnetic field. And it's basically a magnetic tug-of-war between the two poloidal fields of the sun's north and south poles. Nothing to write home about there. We do see some distortions in the eastern portion of it, and that's associated with Sunspot 2765 primarily. We see a massive shortage of electrons starting from a big storm back in August, coming down to now where it's just getting flatter and flatter. Lower highs, lower lows, very low electron flux. So here's the daily, and that's the GOES greater than or equal to 2 mega electron volt electron flux. Here's a total electron content forecast. And we do see some anomalies there in the southern hemisphere once again. Northern Antarctica. So here's the ionosphere map. This is 6 hours of data. Here's the latest image. That one's 8:45 Universal Time. And it's looking fairly normal there. We did see a pretty strong earthquake in Iran. We'll get to it. First, we're going to scroll up the list. Nothing over a 6 magnitude from what I saw. A deep quake struck New Zealand. Shout out to New Zealanders. Are you watching Eddie Dawkins? That 4.5 magnitude quake at depth. Heads up New Zealand. You could have a larger quake at the surface, which would be more like a 5 if that quake struck at the surface. Here's that 5.7 in Iran. There's the location of that. Doesn't look heavily populated. And for that, we thank you. Shout out to Iranian viewers. Please leave a comment if you're viewing from any place in the Middle East. Shout out to Adnan Afif and Youssef Afif. Alright, here's a 4.2 in Argentina. That one's at depth. Western South America has been seeing deep quake after deep quake for ages. Here's another one, a 4.5 at Bolivia at 223. Here's a 5.0 at Indonesia. It's at 126 kilometers. And then about a half an hour later, another Indonesian quake. Some aftershocks striking Iran. In between there. Oh, there we go. Oh, wow. I almost missed that. Check it out. Largest quake of the past 24 is this 5.9 at Fiji. And we have seen quite a few deep quakes in this ocean rift zone here north of New Zealand. So that is the deep quake capital of the world. Check it out. 5.9 magnitude at 548 kilometers depth. That would be like a 7 magnitude quake if it happened at the surface. Small deep quake at Alaska. And then another deep quake at a 4.3 magnitude north of that area. Let's check out that location also. That one's northeast of Fiji. Shout out to our viewers who have vision so terrible they can't see anything that I'm looking at. Next, looking at Kluchevskoy and other volcanoes at volcanodiscovery.com. To see Kluchevskoy still erupting, flight level 20,000. Shivaluch exploding, flight level 12,000. Aso, flight level 5,000 there. Sakurajima, flight level 7,000 there. Sanjiang Api back on the list as it explodes in Indonesia. So seismic and volcanic activity kicking up at the same time. Flight level is 10,000 feet over Sanjiang Api. Semeru, flight level 13,000 there as it explodes. Sangay, pyroclastic flows. Oh, geez. Let's hope nobody was anywhere near those. This is why I tell you not to build a campsite at the foot of a volcano. Revenador exploding, flight level 14,000 there. Sabancaya exploding, flight level 23,000 there. And sporadic emissions of volcanic ash at Nevados de Chilean are a reminder to not attempt to pole vault the caldera. Because one of the reasons you may not want to pole vault the caldera is because you could find out that your pole vault, that your pole for vaulting, your vaulting pole, is made in China. And since you're made in China, you're fired. Fired. Now, we've got a section in smashomash.com/forum in the general science section about insanity. It's called the Insanity Files. And basically, you could pretty much take most news sources right now and just scroll down and just put every article. So if anybody would like to update our Insanity Files to include everything, such as London Mayor Khan setting up a commission to review all landmarks to ensure they comply with diversity. World Bank forecasts subdued recovery. And Paul Craig Roberts asks, can we survive our own collective stupidity? Well, salute to Paul Craig Roberts. As the masks speak. And, yeah, geez, what is going on with that? Let's talk about MANSA. Or you could say MANSA. I don't know. I think MANSA sounds better. MANSA. No, not Mansa Musa. A different Mansa. Not Mansa Musa, the warlord from the Mali Empire, a West African state. I'm talking about MANSA,